Hello everyone, good afternoon. Welcome to the class ECE341, the probability and stochastic process. Today we will consider a different way on the estimation. We will estimate the random value. Alright. ECE341. 12th week. This is Friday's class. Okay, we will estimate x from y. Yeah, just things like that. Okay, so what is the problem? We have random variables x and y. We have two random variables. And we have some records of the data. We have x1, y1, x2, y2 until xn, yn. Now we already have this data. Now a new observation, a new sample of y, of x and y, and y. Y. We have x0 and y0, new samples. But we only know one of it. We know y0. Then try to estimate x0. These two random variables, you can think they are kind of a pair of values. Then you have record of both x and y. Then the last one, there are two more values coming, but you only know y0. You try to estimate what is x0. Okay, this is the problem. To find this, we use a method we call it a linear regression. I put it here. A linear regression, the idea is like this. We put a y, we suppose y is given, right? Y is given, we want the x, so I put the x here. Right? Y is this x. Then you can have pairs like x1, y1 is here. Then you have x2, y2 here. Right? This is x1, y1. This is x2, y2. And so on. You have, depending on how many data you already have, right? You can have some point. Then you find the relation. You suppose x equal to a, y equal plus b. So like this. And not exactly the same. It's kind of approximate. A relation between x, y. We want this. When you determine this one, that means determine a and b. Then you can have x0 is what? Is a times y0 plus b. So the problem is here. Try to determine a, b from xi, yi, I run from 1 to n, the recorded data. Okay. The problem to solve it is like this. So we call this is a linear regression. This is a method. You give a straight line to approximate the relation between x and y. Now here I gave you how to do it. Look at it. We want estimate like this, right? We want estimate x0 from y0. Use this formula. Then we need to determine a and b. A and b it gives this relation, right? X equal to AY plus B. So for every xi and yi, for the recorded date, right? For the recorded date, you have these. Then we can write these in a matrix. Now I prefer write on my paper. Okay, you can read the notes, read that file. You can also follow my notes here. Now we have xi equal to ayi plus b for every I, right? I run from 1 to n. So let me list all the data here. x1, I put y this side. A y1 plus b equal to x1. A y2 plus b equal to x2. A yn plus b equal to xn. Like this. Here a, b, they are unknowns. And x1 to xn, y1 to yn, they are given symbols. Right, we already have them. Yeah, so we have this one. Right? We have this one. Then we try to write this in a matrix form. A and B, they are unknowns. A and B are here. This side just the column x1, x2 until xn. Okay, this column. And this side, the coefficients y1 and y, right? The unknown A has coefficient y1. Unknown B has coefficient y. So here's y1 and y. Then the second equation, the coefficients are y2 and y, right? y2 and y. And so on. The last one is yn and y. Okay, so we have the equation right in matrix form, looks like this. Then we try to solve it. Solve equation in matrix form. You just use the inverse matrix, you can have it, right? Okay. Ax equal to b, then you can have x equal to a inverse b, right? Remember, this is the very basic thing in the linear algebra. But now this one you cannot have inverse. This is not a square matrix. Okay, yeah, this is a general, not a. Now here I use this one as a. Then I have a u equal to x. Now, this is x. This is a u, and this is a. Okay, how to use this formula? We want the inverse. So I times the transpose in front of it. A transpose A u equal to A transpose x. Here A transpose times A is 2 by 2. This is 2 by 2. Then I can have inverse. So we have u equal to A prime A inverse times A prime x. Okay, we got it. We have these A and B, right? We have these A and B. Then x0, it is just ay0 plus b. That's it. So this method, if we're working this way, is quite simple. Yeah, the only thing is you put the data x and y here in these two matrices. This is capital A, this is x. Then use this formula. You use this one. Determine A and B. A and B are u, right? U is A and B. Then plug in here, then you get the estimation. This is estimate. I put the hat. This is estimate. This is estimation of x0. Alright. We can do an example. Okay, here I have homework problems. We can do this problem but with different date. Okay, different date. Here I have 30 symbols of y and x, and now I have a new y0, it is 55. we want to find the related value x0. What is that x0? Okay, so this is a problem. We need a linear regression. We find a and b firstly. Okay, we want to find these a and b firstly. And we find these two, then I use this formula to estimate. Example. We have x equal to something, y equal to something. Then, of course, we have so many numbers, so the better way is to use computer. If you want to calculate by your hand, it's also fine, but that will be a lot of calculation. So, my lab here. My lab here. Let me write the function. Now where it is? It's work. We go to the 341. Okay, it's here. Let me edit a new file. This is it's a Friday's class 12F. Okay. Just I say lecture 12F. Okay, edit this one. Great. Then I need x. X is here. Okay, I can create x in different way. I just create the value of x. All right. Okay, so first one, I create x and some symbols of x and y. All right. Then I use a w, which is a random. Okay, we have two random functions. One is just random. This function will give us the random value with the distribution is a uniform distribution, uniform between 0 and 1. And actually we have more functions that can give random value. For example, we can use this one, random. By random, you can put the name of your distribution, like I can put normal distribution. This is Gaussian distribution. And we give a 0 min, and the variance is like 1. This is standard one, right? This is standard one. And how many numbers I want to have to put in W? I use 2 rows and like 100 columns. Then I have 100 numbers. Let me put n here. N equal to 100. N to 100. Then I can change this n to change the number of the symbols. Here's n. Then I have n symbols. Now n is 100, so I have 100 symbols. If I change n to be like 10,000, then there will be 10,000 symbols. Okay, this W will contain two rows. I will use 1 row for x, 1 row for y. But now they are same thing, right? Both are normal distribution with 0 min and unit variance. I make some change, like I use a matrix A, not A will use later. I use a P as a matrix, which is random, just 2. This is 2 by 2 matrix. 2 by 2 matrix, let me times something. I minus 0.5, so it is centered, right? I just said the random R8 and D, this function give the distribution is between 0 and 1. Normal this is a uniform distribution between 0 and 1. Now I minus 0.5, then the distribution will be between positive and negative half, right? So be symmetrically. And I times number like times 5. Okay, so make it a little bit larger. Then I use Z equal to P times this W. Okay, by this way we have 2 columns, 2 rows, in this Z, I have two rows, and they are not just independent random variables, they are connected. For W, all the numbers, all the symbols, they are independent. And I times P on in front of this W. Then Z is every number of Z is a combine of both values, right? So they are not is a mixture of both rows, so they are not independent of each other. Okay. Then I use X or equal to this is a Z, the first row, like this. This means the first row of Z, and Y equal to the second row of Z. Alright, we have these two X and Y. Now I want to find A and B. How to get A and B? We have the formula here. Not here. Let's see. Okay. We have formula here. So first one, you need to know A. We need this A. I need this column as X. This is A. So X is just X. We already have X, right? We already have X. So X, we just need a column as X. Here my X is a row, and this one I need a row. Okay, I said both are rows. I put the prime here, the transpose, then both are row vector, right? And I need A. A will be Y, the first row, and followed by another row of 1. So they are ones of the n row and one column. Okay, this is A. Then I use U equal to it is A prime times A, and the inverse, I need a metric, right? Inverse of A prime, A times is this one, right? It's this one, times A prime and times X. Okay, then I get U. I can show what is U. Alright, then the estimate of x0. Okay, it is just that one. I don't do it, but we can show this line, right? Actually, we will have a thing looks like this. So we have some dot, and we can have a line. And let me show what is this line. So I need a plot x and y with dot. This will give those points. Let me run firstly. Check is whether it works. So far the codes are good. Okay, just save it. Something wrong. Okay, in the line, random, normal, or maybe just a norm, no O, no AL. Too long. They do not. They just use norm. Like this way. Okay, you see. Yeah. These are Y, Y and X. Sorry, I need this is not Y. It's Y and X. Wrong way. Y and X. Okay. This is Y. This is X. So okay. It's like this. Okay. Yeah, this is randomly. Every time when I run it, they will be different. See, different. Okay. Yeah, every time I run it, it looks different. Okay. Then I already have the U is A and B, right? A and B. That will be Y will equal to, okay, so let y equal to, just I run from, like here is run from negative to positive 8. I still use this one, from negative 8 to positive 8. I use this as y. This is y just for that straight line, the regression, the line of the regression. And the x will be a is u of u of y is a, right? U of y is a times y, and plus b is u of 2. So I have x. Then I plot it in the same picture. So hold on, and plot. This is a y, x. Okay, in the front leg close. Okay. Oh, you see? Then we have a straight line looks like this. Oh, this is my line is x run from negative positive 8, but my data is only this part. I can make it shorter. Like 4 to 4. Yeah, this one. Okay. Those dots are the samples x and y, and this straight line, it is just ay plus b. It's just this line. Yeah, it depends. Every time I run it, I get different thing, right? Yeah, depending on the date. Every time I run it. Okay, so things like this. Alright. Okay, so this method, you can have this straight line. Then, if y0 equal to like just 55, right? If we have this, then x0 will be y0, 55, y0. Like this. If x0, if y0 is 55, then x0 is y0 times that a is u of 1, and b is u of 2. Now this is the estimation. I can work like this. For example, here I add one more, right? Then I have more value. One more value, and we can do all these things similar. But last one, I have x0. It is just a z. Let me see. X0 is z of the last number, so it is a first row. X is a which row? Y is second row. So y is the second row, the n plus 1 number. N plus 1. Okay, suppose this is y00. Alright. Y00 is this one, then x0, and we have our x0 is z1 at n plus 1. Right? This is y x0, but our estimate I say this is hat of x0. It is u1 times this one. Okay, we can show these three values. Then let's run it. Good. I got something wrong. Oh, this is n plus 1. Yeah, and this one I also need to change the size. Here's n plus 1. Alright, I have this. And those, okay, y0 is this one, x0 is this one, but estimated is, oh, it's not so good, but if we put it in the graph, you can see how it looks like. Let me also plot this is a y0, then x0. I use a diamond for it. Okay, and then y0 and the hat. Y0. Here I use a circle for it. Alright, let me run. Can we see? Do I have diamond? Here's a diamond. Diamond's here and with the circle. Circle disappeared. Oh, circle should be here, right? Circle is very close to 0. Okay, the circle is too small. I can't see. Let me see. Can I make it large? Diamond and not circle. It's it's circle, not C circle. Sorry. I see. You see, diamond is here. And the circle is here. So we use this circle value as the estimate of this diamond. Our estimation is always on this straight line. If we change a different one, let me run it again. You see, the diamond is here. Make it large. Yeah, the diamond is here. This is the neck, that is according to y0 and x0, but our estimation is on this line. So we use this circle value to be an estimation of this diamond value. Yeah, it makes sense, right? We suppose the x and y, they have a relation just given by this straight line. Yeah, but the real value will be a value with some random, because some random things is not exactly the same. You have some errors. Okay. All right. So this is the problem and how to solve it. But actually, we have more things. Let's go back. Here, I gave this formula. This is just a formula you can use MATLAB. Use MATLAB. Write all the coefficient in a matrix way. That is very convenient. And this is common use formula. Actually, this formula coming in the I don't know how many years, maybe 100 years ago. That is the time people do not have computer, and when people want to do some work like this kind of estimation, they need a calculate, they need some formula. So the formula is like this. It's this part. Yeah, this part. Alright. This one. So here M, this capital M N X Y, that means this is the mean of X times Y with n symbols. Let me write it here. Okay, formula. Formula 1, it is just that one, right? It is just that one. A and B were equal to A prime A inverse times A prime X, where X equal to X1, X2 until Xn, and A equal to Y1, Y2 until Y of Yn with another one column, the column with ones. This is A. This is A. Then we have another formula. We have A equal to, it is a fraction, it is this one. It is a mean of X times Y with n samples minus mean of X with n samples times mean of Y with n samples. This is a numerator. And denominator is mean of Y squared with n samples minus mean of Y with n samples, take square. After you get A, then you can have B. B is mean of X minus A times mean of Y. We have these two samples with two samples. Here, let me explain. Mn xy, it is a summation of xi times yi over n, and run from 1 to I run from 1 to n. And the mean of x, and also similar formula for mean of y, that will be summation of xi over n. I run from 1 to n. And the mean of y is similar, right? And the mean of y squared, actually it is also similar, but let me write it here. This will be summation of yi squared, I run from 1 to n over n. Now we have these. We have these. Okay. And you see, what are these? Here just another one. Formula 3. That is A equal to the covariance of x and y over the variance of y. And the B will be, it is E of x minus A E of y. Now we have this one. We can compare formula 2 and 3. Actually, they are same thing, right? What is a covariance? Covariance, we know it is E of x times y minus EX times EY. Right? And the variance of y is E of y squared minus EY squared. Right? We have these two. So you plug in, you can see the covariance, it is just this one minus this one. And you replace these by the mean. Actually, this is a moment method, right? Moment method for the estimation. We use a number to approximate it. So this is just this one. Right? X, Y, or this one, X, I, Y, I times together, do summation, divide by n. So this is the mean value of x and y based on these n samples. This is this one. And EX now is this one. And the EY will be, yeah, you just replace this by y. Let me write it. And y, Mn of y, it will be summation of yi over n. I run from 1 to n. Right? Yeah. So this one is just this one. And these two are same thing. This one will be this one will be this one. Then you have this A, the formula on A. and B similar. Alright, so basically these three formulas, they are same thing. Here, from here to here, I just leave it here. If you are interested, you can do calculation. Just plug in all the value here inside, and finally you can get this. Lot of calculation, linear algebra calculation. Alright, yeah, it's not complex, but it's long. It's a lot of steps. Alright, and here I just gave the formula here. Alright, you know how to use it, that will be fine. But the difference is here. This one, for this formula can be also used from the distribution. Like you already know the density function or the mass function, then you can calculate A and B by this way. You do not need the symbols. So this one you can calculate without the symbols. You just from the functions you can calculate. And this one or this one, you have to start from symbols, right? All these values, they are coming from symbols. So you know symbols, you can do this calculation. This one is both. If you know the function, the distribution function, the transfer distribution function, the PDF or PMF or CDF, then you can find these by formulas, and then you can have A and B. And if you have symbols, you can just use the moment method to approximate these values. Then you can also find them. Alright. Then we can see how to get these values. How to get these values in MATLAB. We can also get this in MATLAB. We have MATLAB function. One is min of x. One is a covariance of x and y. We have these two, and we also have the variance of x. Right? We have these three. These three, the meaning is this one, it is just as same as us. It is a mn of x, and this one actually it is s squared. Not this one. It is a divided by n minus 1. Remember last time we gave it is s squared 1. And this is also this is a little bit complex. I will explain it. Okay. But it is also divided by n minus 1. Divided by n minus 1. Okay, here, do I need to put it here? Yeah, we can use another u. We have x, so here we need to calculate by covariance over variance, right? So we can calculate covariance as I use a matrix K is covariance of x and y. It's a K. And what will be K? We can see. Let me run. Okay, here you see, K is a square matrix. It is square matrix 2 by 2. Then what are these elements? You can type help. Help covariance. Just covariance to see what it is. If x, okay, this is a single vector that will return the variance, and this one, no, I'm using this one. This one normalized by n minus 1. So that means when you take average, you need it divided by n minus 1 as the same way as in s squared, right? And n is the number of observations, number of samples. And these make these to be an unbiased estimation of the covariance matrix. So here we have concept covariance matrix. So what is a covariance matrix? Let me write here. Covariance xy equal to this one, variance of x, variance of y, and here is a covariance of x and y. Here is a covariance of xy, like this. Okay, this is MATLAB command. MATLAB command. This side is a MATLAB command. Okay, this one, and this is just our notation. This is covariance. Covariance of x and y. Right? Covariance of x and y. These two are variance. These two are variance. This one is in MATLAB. This gives us a matrix, and this matrix contains 4 numbers. They are these 4 numbers. So here, when we run it, we get this k. Then we have the variance of x, variance of y, and covariance between x and y. All right. Then what is a? If we use this formula, if we use this formula, it will covariance over variance. So it will be, I say this is a AA equal to the covariance, that will be k of 1 and 2, that this element is covariance of x and y, and divided by covariance of y, so there will be k 2. Alright, this is A. And the B will be mean of x minus AA times B is mean of x minus A times mean of y. Right. Mean of y. I have this one. Alright. And the U, I solve that and get the U, right? What is it? What is A and the B? U, yeah, use that one. Okay. Then let me run it. Okay, when I run it, I have U here. This is a U. We use a matrix form, right? And now we use the covariance over the variance. Same thing, right? Are they same? Yeah, the same, right? And compare with this, right? They are same. So you use either way, it works. It works. But here, actually, you should know when you do the calculation. In this formula, in these two formula, the variance is replaced by s squared, and the covariance, it is actually it's a summation of those xi minus ex times yi minus ey over n minus 1. Yeah, over n minus 1. This number is this one, not this one. This is matrix, not matrix, not this one. This one according to this one. Denominator is n minus 1. Numerator is xi minus ex times yi minus ey. Then do summation. Then take average. You get the covariance. Alright, it's like this. So when you divide it by n, when you take the average, now this is not exactly average, right? Average, you have n term, you will divide by n. But now it's divided by n minus 1. This is we want to keep the unbiased estimation. Remember, we have introduced that. Let me help. Covariance, right? Last time we have introduced the unbiased estimation. Then for variance, you need to divide by s minus 1 is here. Yeah. It's normalized by n minus 1, where n is the number of observations. So we have this one. What else I want to say? Yeah, I think that will be all. So that's all for today. We just introduced one method to estimate a random value. This is an estimate and random value from some given observations. Okay, the method is called a linear regression. If you are interested, you just search online linear regression. You can have a lot of more information than here. But the main point is just this part. All right, and this one used in a lot of places. A lot of applications. Where you have one observation, you want to know another value, right? Yeah. I still have some time, but I'm done. So see you next time. And today's Friday, so have a good weekend. See you next week. Bye bye.